I audible?
Yes, yes.
Yes. Is my screen visible?
Yes, yes, man. Yes, sir.
Yes, sir.
Okay, okay. So, in the last class, we have just discussed the basics of NLP, just introduction. Today, what we'll do, we'll discuss basics of ML, which is basically required for our NLP task. As I know, some of you have already know this ML part, but some of you also do not have this knowledge. So let me go through the basics of ML. So the question here is actually why we need to learn ML before NLP, because we know that the basic idea of solving any NLP problem is using data, and whatever problem we have that cannot be solved using traditional programming approach. Okay, so that's why we need ML. So that means here the key idea is ML is not NLP is nothing but we need ML, and that ML will be applied on the text data. Okay, so you just see, we know that machines cannot understand text directly. You see, machine directly, if you give any problem on ML, let's say you say that this is the text, can you write a program to say that whether that text is positive or negative? Or if you have a email, can you write a program to identify whether that email is a spam or not spam? So you cannot write. That's why there comes ML for our help. So for this reason we are using, because machines cannot understand text directly. So and also ML helps learn pattern from data. So if there is any kind of pattern hidden inside a data, or a group of or a bunch of data, that can be learned by the ML. So NLP applies this ML to many of the language problem. Like already we've said that spam detection is one such problem where we can apply ML techniques to solve this problem. So what is ML? So ML is nothing but machine learning. It is the field of study that gives computers the ability to learn without being explicitly programmed. So this is important. Without explicitly being programmed, how we can learn from these data. Okay, and also we can say that it is enable system to learn patterns from data and make prediction. That means if there is any pattern available inside the data where we are unable to write a program to uncover these patterns, for these kind of problem we can use ML. So generally this is the way how we are dealing with ML. We have data, we'll create a model. Once the model is ready, we'll do the prediction or we'll give the output. So let's see basically what is the difference between traditional programming versus machine learning. So if you clear about this, then we'll know why we need ML in many tasks. So for traditional programming approach, what we need? We need basically data and some instructions to operate on that data that we call as programs. So for example, let's say there is a problem to identify or to find out the area of a circle. So the area of a circle is the problem. I have to find out the area of a circle when radius is given. So this is my problem. So for that, what I need? I need data. What is the data? Data is the radius. So I need radius. Okay. So I need the radius. So radius is required. And once I got the radius, then I know how to find out the area. So we know that area is nothing but pi r square. So that formula we know. Once I know the formula, that formula or that calculation, I can instruct the computer using some kind of programming instructions, and this called program. And once the program is ready, you give the data to the program. The computer will work on these data according to the instructions given in the program, and it will provide you the output. So this is the traditional approach. Imagine a situation where you have a problem, but you do not know how to solve that problem, or you do not know what is the formula to find out the solution of that problem. If you do not know the formula or the procedure to solve that problem, you cannot write a program. Is it okay? So now the question is, such kind of problem exists in the world. How to solve it? Where we are unable to find out a procedure or a formula to solve it. For example, let's say one problem is I have an image, and in that image, I have to find out whether the image is containing a dog or cat. Let's say it is a cat's image or a dog's image. I have to write a program to identify whether that image contains dog or cat. That means the image is the output. Here image is one data. I give the output. Can we write a program for that? Basically, it is very difficult or quite impossible to write a program to find out whether the image contains a dog picture or a cat picture. So in such situation, as we do not know what is the formula, what is the procedure to solve this problem manually by hand, we do not know, then we cannot write any instruction using any programming language to solve that. Okay, that's why it comes our machine learning. So machine learning is basically is going to rescue you that where you do not know the program. That means this program you do not know. So once you do not know the program, then this program you do not know. So how will create a program? So first, the machine learning job is to find out a program, or we call it as a function, or we call it as a model, whatever you tell. But generally, it will require to first find out a procedure. Once you know the procedure, whenever a new data will come, using that procedure you can solve the problem. So traditional ml traditional programming is can be used where for that given problem, if you know what is the procedure to solve it, and you know what is the data. Of course the data is required everywhere. If you know the procedure, then only you can write a program using any programming language, and the data will be given to that program, and whatever instruction is written in the program, that will be used to solve it. But when you do not know, what we'll do, we'll use machine learning. So for machine learning, what it will take? It will take data and its corresponding output. It's not one data and corresponding output. It needs lots of data. So we need lots of data here and their corresponding output. Okay. Now, as we do not know how the data will become output or what is the relationship between the data and its corresponding output, first we have to find out that. And that means we'll have some algorithms, some programming techniques available which will fit to the computer. That programming technique or algorithm will take data, lots of data, and their corresponding output as input. And this programming technique which is running inside the computer produce a program. Okay, actually, this program is not the program what we generally write in traditional programming. It is a kind of some abstract way of saying that it can produce a program. Once you know the program, then whenever a new data come for this solve for this for that problem, you can use that program to solve it. Is it clear? I'm putting in another way. So let's say for a traditional problem solving using traditional programming approach, what we first need, we have to gather the requirements. What is the problem? We first gather it. Once we know the problem, first we'll find out whether there is any procedure or formula available to solve that problem. Once we know or find out that yes, this is the procedure, or this is the formula to find out the solution of that problem, then use that formula or procedure. Using any programming language, you can write a program, write specific instructions. Once the program is ready, now you give this program to the computer and you give the required input data for that program, then the program will be executing on this data and it will give you the result. So the bottom line here is that the traditional programming can be used where you know the procedure or the formula to solve a problem. Where you do not know how to solve a problem, in that case, what we'll do? So we'll use first to find out that program. So here, for that, what I need another ML algorithm, some machine learning algorithm, some machine learning programs which will be used by the computer, and they will take lots of data and their corresponding output or result. And the ML model, or this or the ML algorithm, what it will do, it will try to find out a mapping between this data and their corresponding result, a common mapping it will try to find out from these lots of data and their results. And we call this mapping or a function as a model, or indirectly I can say it is a program. Actually it's not a program, it's similar, it will work like a program, but it is a model. In machine learning world we call it as a model. It is nothing but a function. It's a mapping function. What it is doing, it is trying to find out the mapping between this data and its corresponding result. Once we have that, then the model is ready. If a new data came for that problem, then you give this new data to the problem, to the model, and it will solve it. It will give you the result. Like here, once we know the program, you give the data and it will provide the result. Similarly, here when we do not know the program, first we have to find out that. So for finding out that program or model, we need the techniques of ML. So ML will come to rescue in those situations where you do not know how to solve it. If you know how to solve it, then we don't need any ML technique. Okay. So this is used for only some tasks. Not all tasks can be used for, means all tasks will not be solved by ML, because if you have already programs or procedures or formulas, then you can directly use the traditional programming. Okay. Now, question is when to use machine learning. So I've already told you that when you do not know how to solve the problem, you do not know the procedure, you do not know the formula, at that time you can use. This is number one condition. Second condition, the data what we are using to find out the mapping, you need lots of data, and the data must contain some kind of relationship, some kind of pattern. If that means I have data of input and the corresponding output, and for these input and corresponding output, there must be some pattern hiding in the side the data, which we do not know. If we know it previously, then we can use traditional programming language to write that program, because you don't know what is the relationship, what is the formula, how this input becomes output. Okay, so for that reason, we can use, in that case, we can use ML. For example, if you try to say that I have a problem. That problem is to find a lottery number which will be going to win. Which number? So basically, even if you collect lots of data of lottery winners from previous time, that will not give you anything. We cannot use ML because there is no inherent pattern inside it. There is no relationship between the lottery number and winning. So we cannot use that. Wherever we believe that there is certain kind of pattern, there is certain kind of formula exists between input and output, and we are unable to identify it, in that situation, we can use ML. Okay. And for that, what we need, we must have enough data to discover this pattern. It's not only one or two data examples of input output. We need lots of data. If we have, then only we can uncover this pattern. Okay. So it is difficult to formulate a mathematical expression. Otherwise, we'll just use it. This is the third one, that when we are unable to find out the expression, how this input will become output, in that case we will use, suppose I already told you that for finding the area of a circle, we know the formula. This is the mathematical expression. If radius is given, the mapping is that area is equal to pi r square. So that is the mapping function. So here f of r equal to pi r square, because we know that function. But if you do not know the mathematical expression, how to solve this for a given input for a particular problem, at that time also we can use ML. Is it okay? Is there any doubt within this?
No, sir.
Okay. So let's move. What are the different types of ML? Basically, ML is consisting of three different types. One is supervised learning, unsupervised learning, and reinforcement learning. So these are the basic three types of ML. ML is categorized into these three. So let's see one by one, and basically we will discuss more on supervised the case Unsupervised reinforcement we will not discuss, because our NLP is mostly focused on this supervised part. So we'll discuss only that. So let's see what is supervised learning. So supervised learning means where we need labeled data. Means for that, to uncover these patterns from these data. So we need what kind of data? Labeled data means we must have some input and its corresponding output for that problem. Okay. If we have that, and not only one, lots of such kind of data if available, we can use that to solve a problem using ML, and that kind of problem solving is called supervised learning, because it is supervising. This is the input, this is the output. We have lots of examples of this input output pair, and the machine learning models or algorithms which will use this to find out a mapping between input and output, we call it as supervised. So the first thing, what is supervised? It must have a labeled data to train the machine learning model. So in labeled data means the output is already known. For every input, the output is already known for that problem. And the model just needs to map the inputs to the respective output. Means we have to find out a common mapping. Let's say I have 100 such examples. Example 1, this is the input and its corresponding output is 1. And you have similarly lots of examples. So we have to find out a common mapping between these two. And that mapping is nothing but a model. So that ML algorithm is trying to uncover that model or that mapping. An example of supervised learning is to train a system that identifies the image. Like I've told you that whether it is cat or dog. So what will do? I will have lots of cat image and the output is, that means this is the image, output is cat. Another image, output is dog. Another image, output is cat. And lots of such type of image and its corresponding output will be available. Then we can feed this input output pair to a machine learning algorithm, and the computer will use that machine learning algorithm and input output, try to find out a mapping, and that mapping from input to output will be used for future solution. That means in future, if you got a new image and if you feed that image to that model which is already learned from the lots of input output pair, then easily it can identify whether it is dog or cat. Here we don't know, we means we are uncovering, but we do not know what is the behind picture, how, what is the actual function, that we don't know. Still it is perfectly doing well. And one thing you remember, that like in traditional programming where you know perfectly the procedure and it will give you perfect solution, in machine learning algorithm you cannot get 100% accurate solution. Okay, because it is trying to figure out, and that's why there will be some error. Okay. So that's why when you have a problem which is very critical, okay, means it's a solution is very critical to somebody, then in that case you cannot use ML. For example, let's say in health sector. So for diagnosing the disease, it's okay, but it will help as a extra tool. But if you only depend on that tool, that machine learning model, because you know that there is error, so it might be fatal for the people. So that's why it can be used as a aid to the or helpful tool for the doctors. It cannot be solely depend on that because it has some error. So another example is learning is to train a system that predicts the price of a house price prediction. You have lots of means there is no formula how a house is converted to its price. There is no such formula available that if you have this is the house and I give this input to a particular program, it will give you out. You don't have. So for that type of problem, what we need to collect lots of previous house and their prices which are already been sold, and we'll try to figure out by using a machine learning model that what will be the mapping. So that in that case we can use ML. Okay, so this where the label data is there, we call it as supervised learning. And again, supervised learning is divided into two categories. One is called classification, another is called regression. What is classification? So classification means if the output of that data set of that problem is a categorical data. Categorical data means either it is let's say disease or no disease, spam or not spam. That means you want to identify whether it is a cat or a dog, whether it's red or blue, or if whether a person will get A grade, B grade, C grade, or D grade. So these are called categorical data. So if you have a problem and where the output is a categorical data, we call such kind of problem as as a classification problem. Means we have to classify out of all these categories which one will be the answer. Instead of regression problem, in regression it is giving you a real value. Real value means a number. So for example, that house price prediction, what will be the price of a house? The price of a house can be a number, it can be any number. Okay. And similarly, for stock market prediction, so stock market prediction means what will the price of a particular share. So it's another price. So price means it is any real number. Like you want to find out the weight of a person. So weight is a number, it is not a category. So when you have to deal with this kind of output data where the output is a real number or any number, then we call this kind of problem as regression. So these are the two categories, and basically we'll mostly focus on classification part in our NLP, because NLP in most of the problems are based on this categorical output, whether a email is spam or not, whether a text is sentiment is positive or negative, whether a text is means a post is sarcastic or not sarcastic, whether a some comment is means derogatory or not derogatory. So this kind of job we will going to do. Okay, so most of them will belongs to classification. So let's see. So for classification, what we said that we need a data set or a lots of example, and we combine these into a set of data called as a data set. So let's say how the data set will look like. Okay, for example, it's a two class classification problem, that is recognizing that a person has a diabetic or not diabetic. So what I'll do, we will have to collect lots of examples, previous examples which are already been means tested. And for them, let's say I have collected for 1000 patient. For each patient I have collected their age, their weight, their blood pressure, their sugar level, and cholesterol. So these five attributes I have collected, or five information I have collected for every patient, and whether they have detected previously, they have already detected diabetes or not. So having diabetes or not, this will be the output. So that means this is called your data set, which has some of these attributes, and in ML we call them as features. Features means age, weight, blood pressure, sugar, cholesterol. These are the features, or also we call them as independent variables because they are not dependent. And you're having diabetes, y is your output, or it is the target, or dependent variable, because this variable is depending on these values of these features. So these are the features. This output is your label or the target. So that means to solve a problem like whether a person is diabetic or not, giving these information, we cannot write a program in traditional programming language, because you don't know how these information will translate to yes or no. We don't know. There is no such formula available. So we cannot write, or there is no such procedure also available. We cannot write. So what we'll do? We'll take the help of the ML. So the ML will do what? You just collect lots of examples of such previous patient's information, then create a model using some ML algorithm. What the ML algorithm will do? The ML algorithm will try to take these input and output pair and try to find out a mapping between these input and output pair. And that mapping, once it is ready, that mapping can be solved as a program or a model for future data. Once the model is ready, we got a new patient's information like this, x new 1, x new 2, and this. You just give these information to this model, and the model will predict whether it is yes or no. So the process of getting the model out of these data that is 1 to 1000, we call it as a training. So we trained a model. Means the process is called training. Once the model is trained, then you can use that for these new patients information. It will give you the output. We call it as inferencing. Is it okay? This is one way. And here the output is categorical, because here it is yes and no. It is a binary classification problem, or a two class classification problem, because the class will be either yes or no. Okay. Similarly, another two class classification problem is movie recommendation. So movie recommendation, let's say I have movie names. Let's say R number of movies are there, M1 to MR. And for every movie, I got some means let's say the star ratings, user 1, user 2, user 3, user M, some M number of users rating I got. So these are given, and whether they have liked it or not liked it, it's also given. So now this M1 to MR of input output pair will be used to train a model. So here also you see the output is yes or no, whether it is you recommend it or not recommend it. So there is no such formula to find out this output. That's why we are taking the help of the ML. So once you train the model using this input output pair, using any ML algorithm, once the model is ready, now you got a new movie and their rating, then easily if you feed this information as input to the model will predict whether it is recommended or not recommended. Okay. So we call this a two class classification. Because here the why it is called classification, because the outputs are categorical data. Similarly, for image, let's say it is also a classification problem. Why? You see, I have lots of image of digits, handwritten digits. These are handwritten digits. And what I have done, I have collected individual digits and their labels. Their labels means this one is 3. I have labeled it. Means this is the actual output. This is the 7 actual output. So what I need a program or a model. When I will give you a one handwritten digit, what it will produce? It will produce what is the value written in that image. So let's say if I give this handwritten 8, so it will produce the output as 8. So here also it is a classification problem. Now you see, I have already told you that the number, if the output is numeric value or real numbers or any number, then it is a regression problem. But I am telling you now here it is a classification problem. Even if these are the numbers, but these numbers are fixed. That means 3, 3. So how many numbers are there? 0 to 9. So there are only 9 possible digits available. So for every handwritten, either one of these digits will be the answer. So it is a multi-class classification problem. It is a categorical value. Even if they are numbers, but they will not treat as numbers. Rather, they will be treated as categorical value. So there are 10 categories. Each category, even if it is a number, but it's not used as a numeric value. So we call also it can be called as a 10 class classification problem or multi-class classification problem. So here also you can train a model which will take this input output pair and find out a model, so that when you give a new image of handwritten digit, it will predict what that digit is. Is it okay? Next example, let's say some regression problems. So in regression problem, what I have told you, that the output is a real number. So here, let's say one problem is sales. That means a company is there and they spend some money on advertising, and the advertising values are there on TV, radio, and newspaper. And for that company, what is the sell? How much sell has been done? Sell in rupees or any currency. Now, what you do? Now, for that also, you don't have any formula to find out if these values will be given, what will be sell. Company wants to know, if I will spend this amount of money on these mediums, what will be the sell in the next year or in subsequent years. So that needs to be, there is no such formula. So what we'll do, we'll take the help of the ML. What the company will do, the company will have its old records. That means in previous year's records, in each year, how much they have spent on TV ad, on radio ad, and newspaper ad, they have collected. And in that year, what was the sale? So now you have this data. Then let's say there are n number of such data available. Now you can create a model or train a model using these input output pair using any ML algorithm. And once the model is ready, now you give some values for TV ad, radio, and newspaper, then it can predict what will be the sell. So here sell is a price. So price can be anything. It can be from infinitely many values. It can be any value. It's not category means it is fixed, but here it is not fixed. So that's why this kind of problem we call it as regression problem. Is it okay? Similarly, another regression problem is that predicting rainfall, quality of rainfall, how much rainfall will be there. So, image of cloud, you take image of cloud for third week and fourth week, then you have to predict what will be the rainfall. So, your rainfall, you see, is nothing but a number. How much rainfall? So, as it is a real number, it can be any value. So, we call it as also a regression problem. Is it okay? Similarly, stock price prediction. So stock price is also a real number. You give some information or some future values. Let's say like risk-free interest rate, price of gold at that time, price of petrol at that time, exchange value of USD to Indian rupee. So you give this value and what was the stock price at that time. Okay, so once you have this historical data, you can train a model, and for the current time, or if you have these values, give this input to the model, and the model will predict what will be the price. Okay, it's a look simple, but it's not that much simple. So whatever prediction will be given, that you can use for trading. So here, as the value is real, the output is real, so it is also called as a regression problem. So let's see. Who can answer this one? You are running a company and you want to develop learning algorithms to address each of the following problems. Problem one, you have a large inventory of identical items. You want to predict how many of these items will sell over the next 3 months. Problem two, you would like software to examine individual customer accounts and for each account decide if it has been hacked or compromised. So which one is what? So what will be the answer among these?
Sir, option C.
Option C. Treat problem one as regression problem, problem two as classification problem. You see any other one? Anyone else want to add? Okay. So see, very good. So you have a large inventory of identical items. You want to predict how many. The question is how many of these items will sell. So here how many means output is a number, real number over 3 months. So it's a regression. But this one problem two, here the output is what? You would like software to examine individual customer accounts and each account decide if it has a hacked or uncompromised. So here the output is hacked or compromised. So it is a categorical value. That's why it is classification. Very good. Next is this one. Suppose you are working on and your weather session makes one of three predictions for each day's weather: sunny, cloudy, and rainy. You would like to use an algorithm to predict tomorrow's weather. So would you treat this as a classification or regression?
Classification.
Classification.
Someone is written regression. Swarup Mahapatra. Why it is regression? Swarup? Swarup is there? So try to, because this is very basic. Swarup, you have written regression. Why you think that it is a regression?
Saurabh, you just unmute and ask.
Swarup. See, just try to see. Here the output is sunny, cloudy, or rainy. So that means these is three categories. The output can be any one value. So regression, remember, regression means a real number. Any real value, if it is answer or output, then it will be regression. Otherwise, it will be classification. You just remember this thumb rule. Otherwise, because this is the very basic. If you do not understand clearly, then it will be difficult. Okay, next question. This one. Suppose you are working on stock market prediction and you would like to predict the price of a particular stock tomorrow measured in dollars. You want to use the learning algorithm for this. So what is it? Is classification or
It's
regression?
regression.
Regression.
Regression, sir.
Yes, because here
Yes.
you see we have to predict the price of a particular stock. So it is regression. Very good. This one. So some of the problem below are best addressed using a supervised learning algorithm and the others with unsupervised. So learning algorithm. So I have not told you what is unsupervised. Unsupervised is basically where you don't have labeled data. Okay, that means only I have the input features. I don't have the output. So if you have any algorithm to solve this, that is called unsupervised. Now use this idea and find out which one is supervised, which one is unsupervised. First one, given 50 articles written by a male author and 50 articles written by female authors. So there is a machine learning algorithm to learn to predict the gender of a new manuscript author. So
First
it is
one is
a
supervised.
supervised, and what kind of supervised? Regression or classification? First one,
Classification.
Classification.
classification, because you have to find out whether the author is male or female. So category, there are two categories. Second one, examine a large collection of emails that are known to be spam emails to discover if there are subtypes of spam mails. Is it supervised or unsupervised?
Unsupervised.
Unsupervised.
Okay, why it is unsupervised?
Sir, there are no labels for any subtypes.
Yes. So as we don't have given any label, so we have to just discover that label. Okay, so it is unsupervised. Third one, given data on how 1000 medical patients respond to an experimental drug and discover whether there are different categories of types of patients in terms of how they respond to drug, and if so, what these categories are.
Unsupervised.
Supervised.
Yes. So of course it is also because here the labels are not given. Okay, only the feature values are given, but no label is given. Last one, examine the statistics of two football teams and predicting which team will win tomorrow's match, given historical data of teams' win losses to learn from.
Supervised.
Supervised.
It is supervised and
Classification.
Classification.
it is a classification. It's not regression. Who is saying regression? It is not regression because you see, we have to find out whether it is win or lose. The output is win or lose. So it's a category. Is it okay? This one. Which of these is reasonable definition of machine learning?
A. Option
Sir,
A.
option A.
Sir, option A.
Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. You remember that. Means when we are unable to write a program and we want to solve a problem, so machine learning will be used. Okay, that's why it is called without being explicitly programmed. Okay. This one. Suppose you are working on stock market prediction, you would like to predict whether or not a certain company will win a patent infringement lawsuit by training on
Classification.
data.
Classification.
Classification.
Yes, it's class. Yes, because here, see, I am not asking. It is not asking to predict the price of the stock. It is trying to predict whether you will win or lose a lawsuit. So it is classification. Very good. This one. You are working on a stock market prediction. Typically, tens of millions of
Regression.
shares of Microsoft stocks are traded each day. You would like to predict the number of Microsoft. So you see, the output is have to predict the number of Microsoft shares. So the number can be anything. So it is regression.
Regression. Supervised.
Yeah, of course, it is supervised and regression. Very good. So, we'll stop here. In the next class, we'll discuss the ML pipeline. Because today what we'll do, we'll discuss the pandas. Once I cover the pandas today, From the next class, we'll start the pipeline, and according to the pipeline, whatever programming required, we'll discuss. Okay. Okay. I have given you the assignments. Have you done that? That on NumPy? Yes. Okay. So let me quickly go through the solutions of these given 10 assignments. And then we'll discuss. Is there any doubt, or should I continue with the pandas, or should I go for that solution? Anyone has not done or not understood? Okay. Okay. So we'll start pandas today. Let me share the screen. Yes. Yes.
Sir, good evening, sir.
Yes.
So actually, I had a problem about that NumPy actually. The previous day, what you had.
Okay. So
So, one syntax actually I couldn't understand. Like, why is it been written like that?
okay. Okay. Let me share that one. Then we'll
Yes,
discuss.
sir.
Okay. Tell
Hello,
me.
sir. Can you hear me?
Yes. Yes. Want to tell something?
Yes, sir.
Ah.
So in that one-dimensional array part,
Hmm.
it was written, so in the example which you had given, it was written in the type, the D type, it was given
Hmm.
np dot int 16. But
Okay.
why, sir, 16 and 64? Like, why these numbers are, I mean, how are these numbers?
Why these numbers are there? So
Yes,
you
sir.
see, when we have a data type, the data type must be given some bytes in the memory, because it will take some bytes. Okay. So in general, there are different types of integers, because you see, if it is written 16, that means it is 16-bit number. So that means the integer will take only 16-bit to represent in the memory. So that's why the term is int 16. That means int 16 means the what will do? It has certain range. What is the range? Range is from 2 to the power 16 minus 1 minus 2 to the 16 minus 1 to 2 to the 16 minus 1. That is the range. That means between this range of numbers, you can create any number, and that can be stored using int np6 np dot int 16. But if you want a bigger number to store, and to store that bigger number, 16-bit is not sufficient, which is out of the range, then you need little bit more memory to store it. And for storing a bigger number, we need more memory. So for that, I have or the np has np dot int 64, means 64-bit. So it will take 64-bit to store a number. So that means the range of number it can accommodate is more. Is it okay? Is it clear?
Yes, sir. Yes, sir.
Means depending on the memory requirement, depending on the size of the number, you need memory. So if a bigger number to be represented, so more memory is required. If a smaller number is required, need to be represented, so small amount of memory is required. That's why in 32 and in 16, in 64, these things are there. Okay. Any other problem from this assignment?
No, sir. But I have a question, please.
Yes. Yes.
Can you?
Why?
Yeah, with regard to the quiz questions that you asked about weather predictions, we come to consider that is a regression problem, because most of the key output are considered numerical values, not categorical. In the current modern weather systems, we can say that, can we be able to say that it comprises both the regression taxes and classification. For instance, there are some weather systems that can be able to dictate to say, to classify like a storm detections, to say whether it's going to rain or not rain. So it can be able to predict how much rain, which is regressions,
Yes,
and also it can
yes, yes,
predict
yes,
if
yes.
it
So
is raining or
I
not.
got your
So
question.
it combines both the classifications and regressions in the current modern weather systems.
Okay. So that means what you want to tell, that can we combine the everything in one model so that it can say whether there will be rain or not. If yes, how much? Is
Yeah,
it
that you
okay?
what I wanted to say. Yeah, can we be able to say like in the modern weather predictions, it can fall as although a combination of regressions and classification also, since we can be
But
able to measure the predictions of how much rain is going to come over, and the temperature forecasting, which is the regression axis. It can be able to set the rainfall quantity, and also it can be able to say whether it's going to rain or not rain. It can measure
yes,
storm detections, which is a classification taxis. So can we be able to say that the current weather prediction can combine both the regression and the classification taxis? So in case if somebody can be able to say, yeah, it's also a classification, and these are the reasons, it's also a regression, these are the reasons, because it can combine both the two.
okay. So we can model such kind of means we can combine, but what our objective is here is to understand what is classification and what is regression. Okay. So what you are trying to say, that can we create a comprehensive model which will do all kind of tasks, like it can do the classification part as well as it can do the regression part. So we can do
Yeah,
it, but separate models can be created and they will be combined in a one platform, so that whatever data you give, accordingly the model will be got executed, and it will give you the result. Okay. For example, let's say you are telling that these are the inputs. If I'll provide, it will not only say that whether it will be rain or not, but how much. So that means we need two models. So two models will be there inside a particular platform. When you give the data, one model will predict whether it will be going to be rain or not. Another model will say how much. Okay. So we call this as also there is in deep learning, there is called multitask learning. That means in that case we can do one single model which can do two types of tasks. Okay, we call this as multitask learning. That can also be done, or you can stack or combine individual models to form the output. That is a design choice. Okay.
Okay, thank you.
Is it okay?
Yeah, it's okay. Very clear. Thank you.
Okay. Okay. Yes. Any other question related to this assignment, or should we go for pandas? Okay.
Hello,
So
sir.
yes, yes.
Sir, sir, I did not have any question regarding to the assignment, but regarding the NLP thing you told yesterday, I had
Hmm.
an idea. For example, the Gen Z terms like see you and later with the eight thing.
Hmm.
So I have an idea like if we use phonemes, like English phonemes, as and we compare those phonemes to the nearest words. For example, see you. So like C, there can be two things, SWC and ACAC,
SHC.
and
Yes.
using the context of the conversation or the text. If we verify that, then it would be easy to get
Oh,
an
yes,
output.
that can be that can be one approach. That what you can
Hmm.
do, that use the phonemes or sounds. Okay, so you
Hmm.
see, when I say sounds, then it comes a speech, because if
Hmm.
you write it, if it is a written text, if it is a
Huh.
written text, it will not use the sound. It is see. Try to understand.
Uh,
So when you say
okay.
that see you, so in
Hmm.
that case, you can use speech processing, how you perceive the phonemes, and accordingly use the context to disambiguate it. But the problem with the text is that there is no sound. C is
Uh-huh.
C. C is not a sound. You cannot create a phoneme out of a text. Okay, that means again it will be reverse. If you try to convert every word as a phoneme, then from phoneme you go to the text processing part, then only it can be done. Okay, try to understand. But as it is only text, text do not contain any phonemes. Means text itself do not have any sound. Okay, so that is the problem. That is the problem. So try to think what else we can do. So for that, what we can do now? One thing is that you have lots of such sentences. If before analyzing this, what we can do that try to create a label data set. That label data set, what it will do now, if I write see you tomorrow, so what is the exact sentence that will be the output? You just label it. So create a model which will map these kind of sentences to its corresponding accurate sentence in English. There may be some error, but you try to create it, a model. Once you have that, then that can be used for whatever other applications you use, that text can be used. But it's a two-layer process. So when there are two-layer process, the error will be more. Try to, are you getting it? Because you need one ML model. Let's say it is a classification sentiment analysis case. Where people are talking, and they're talking in these small words or which are not in English. Then how to identify whether it's positive or negative? So for that you need a model, but direct model cannot be applied there because everybody is not writing C as a C. Everybody is not writing LTR, L8R is later.
First, we
Someone
need
can
a
write
model to
LTR
convert it
also.
into. First, we
Yes,
need a
yes,
model to
yes.
convert it into normal English, and then we can analyze its sentiments.
Then first you create one model which will try convert it into normal English. Then you can. But here the problem is that as it is a two-step process, there are two ML models required, and every ML model has its own error. So where the error will be combined to give bigger error. So this is a general approach. I am telling you, but you have to think other ideas. How we can solve in one model, then it will be better. Or if you are using two model, what I should do so that the error will be minimum. Okay, because the problem with the non-standard English is that the non-standard is also not standard. The non-standard English is also not standard. Means everybody is not writing L8R. Somebody can write LTR also later. That is the problem. If it is a standard non-English, then it's okay. You can create any one model, it will be helpful. But as there is no such standard of writing, most of them are common, but many have many varieties. Okay, so try to think. Okay, I have not thought, just whatever comes to my mind currently, I will telling you. But you just try to think that what we can do so that in one model that can be done. Okay.
Okay, sir.
Okay, so let's go and discuss the pandas part because that one is very a bigger one. So let me stop this one. Is it visible?
Yes, sir.
Okay. So actually, this is a very long document. I may not cover in 30 minutes. I'll try to cover up to 10. Okay. So up to 10 means how do we apply multiple filters? So, and subsequently we'll discuss when we'll do pre-processing part. Okay. So question is, what is pandas? So basically, it is an open source Python data analysis library, which will be used on tabular data. Okay, and it is being used for machine learning, data analysis, data mining, data warehousing, and other data science applications. And here, as we are going to use scikit-learn, so all our data set, as they are in tabular forms, so to load and do some kind of analysis on that, we need pandas. Okay. So what is the first step? First step is to install. So either you can use pip install pandas, or if you have installed Anaconda, you can use Conda install pandas. So directly it will install on your system. So if you are using Colab, in Colab already it is there, you don't need to install it. Even if you need, you just write pip install or exclamation mark pip install pandas. Then same before using any library, this is the conventional way to import it. So first import pandas as a PD. So this PD is a alias, you can give any name. So now what are the core component of pandas? So basically pandas consisting of series and data frame. So what is a series? So basically series is a column. So what I'm saying that a panda will be work on a tabular data. So a table has rows and columns. So the series is representing every column. So every column is represented by series. And what is a data frame? That the total table will be a data frame. That means this is one column where the column heading is apple and these are the values. Another column heading is orange and these are the values. So this is one series, this is one series. When two series is combined or more than one series combined, we will get a tabular form. We call this as a data frame. So the data frame consisting of these two series, one contains apple, another is orange. Okay. So how to create pandas series? So first we'll see how to create series, then we'll see how to create data frame from the scratch. So series very simple. So there is a function or method called pd.series. So S is capital. pd.series, you pass any list. Okay, so it will create a series. Now when you run this, sorry, I'm not imported it. So import it first. So when you run it, you see pd.series. So a series is created. So one column is created and the values of the column is 2, 4, 6, 8, 10, and the data type is int 64. By default it is taking int 64. These 0, 1, 2, 3, 4, these are called indexes. Means the row uniquely identify the rows of this series. Okay. Similarly, if you want to convert a panda series to list, so this one is a list to series. So pd.series and pass the list. You want to convert in reverse way. So what you will do? Now you will use ds.toList. So this is your series. Sorry, ds is your series. Now dot to list, it will create or reconvert it into your means list. So if you run it, so first one, this is series. Series is created using this pd.series, and ds.toList will convert them into back into the this list. Okay. And we can do some operations on series directly, like add, subtract, multiple, divide to series. So very basic. Just use their corresponding operator for addition plus, for subtraction minus, multiplication star, division slash. Now you see here this series has 2, 4, 6, 8, and this series has 1, 3, 5, 7, 9. That means the number of elements here is 4. Here the number of elements is 5. So the question is, when we add S1 plus S2, then 1 will be added to 2, 4 is added to 3, 6 will be added to 5, 8 will be added to 7. The 9, for 9 there is no corresponding value present in S1. So what it will do? So it will give you, as nothing is available, so it will give you a value called NaN. So you see this is NaN. Okay. Why? What is NaN? NaN is basically a NumPy constant that is not a number. And in pandas, it is being used automatically. It will be replaced when there is no value present. So you have a table and some positions of this table do not have anything, it's not filled up. And when you load that table in pandas data frame, these values or these positions will become NaN. That is called not a number. Okay, so as the corresponding value is not there in S1, so the addition cannot be possible, and that field will become NaN. Is it okay? Similarly, S1 minus S2, same procedure. This is also NaN, and this one multiplication and division, same thing. Now let's see, convert a NumPy array to pandas series. So we already discussed how to create a NumPy array using np.array function. So np.array function, we pass a list, so it become a NumPy array. So the list becomes a NumPy array. In here also, you can directly use pd.series to create a series out of list. But if you have a NumPy array, how to convert them? Same pd.series, you just call pass the numpy array, then it will automatically convert it to a pandas series. Okay. Now let's see how to create a data frame. This is important. So data frame means it must have number of rows and number of columns. Means more than two series is combined to form a data frame. And directly, how can you create? Now, there are many other ways available. One very simple and basic way people have been using, that is called dictionary. So create a dictionary, and let's say this one is a dictionary, and the dictionary has this key, that is apple. These are the values. This another key is orange, and this is the value, and the value here is a list. This value is here is a list. And when you convert this into data frame, how will convert? Now call the data frame function. So pt.dataframe, D is capital, F is capital, pass the dictionary, so automatically it will be converted to a tabular data frame. So now you see, when you run this, it will become a data frame. Now when you print this data frame, that is a data frame name is purchases. So apple and orange become the key value will become the name of the columns, and the corresponding values will become their values. So here also index start with the 0 to 3. The index is auto, so it will auto generated. You don't have to do anything. When you write, automatically it will be created. So this is the way you can create a data frame out of a dictionary. Okay. Or if you need something to be created as a data frame, you create a dictionary first, then call the data frame function of the pandas, then pass that dictionary, it will create a data frame. That means tabular form. So how did it work? Already I've told you that each key value item in data correspond to a column, and the index within the data frame will be given from 0. Okay. Now this index also you can change. Let's say I want to change this index to 2 months. So what I'll do? So I will create call the pt dot data frame, pass the data, and for index, if you don't pass anything, auto index is 0, 1, 2, 3. If you pass the index, there are 4 values. So I pass a list of 4 values. So here the values are June, or let's say Robert, Lily, David, or you can give the month names also. So what you will do, when you run it, it will create a series where the index values, index means the row values, row numbers, row names will be assigned manually by using this index attribute for the data frame. Okay, if you don't give, auto index will be created, that is 0, 1, 2, 3, etc. Okay. Now, if you want to access any row, what you will do? You call the data frame. The data frame name is here purchases dot loc. So loc, and within bracket you pass this index. So the index is June. So what it will do? It will return these 3 and 0 for apple and orange. So you see, apple is 3, orange is 0, and this will return one row, or that particular row for that index. Okay. Next question is, how do I read a tabular data? This is required for our ML as well as for NLP, because we have a data set. Generally, the data set is in tabular form. So to read the data frame, to read the data for the processing of ML, we have to use this one. So one function is called pt.read underscore table. So this is a common function. So read underscore table, here what I have given I am giving a link. So this link contains a data set. Okay, and this data set, the link is cheap orders. So when I run it, automatically whatever data set present in this link is read, and a data frame is created, and the data frame name becomes orders. And if you want to see first 5 rows of that table or of that data frame, you can use the data frame object name, that is orders dot head. So automatically it will give you 5 rows along with their column names. So this is order ID, quantity, item name, choice description, item price. These are the values present. This NaN means in this field no value was there. That's why when it read, it gives NaN directly. Okay. This is a read table. So when you are reading, if you want to change the column names, so what will do, you create a list of new column names, and when you read it, just pass name as this new column list. And sometimes the data is means the data set is separated by some of the delimiters. One delimiter is a pipe. Some data set can be separated by semicolon. Some data set can be separated by, means each in each row every field is separated by tab or any kind of delimiter. If you see, if I will if you open this one, you can see that the data will contain, means separated by this delimiter as a pipe. Okay, so if the delimiter was there or is there, then you will have to provide the separator argument. Okay, so it will read the data in the data frame as users. So if you want to examine what is the users, so you can see this will be users.head. So all these user underscore id is becoming the new column name, age becomes the new column name, and etc. If you do not want to give these columns, means you do not want to give it, so you can use header as none. So if you use header as none and read it, and again if you display the this data frame, you see there is no header. 0 1 2 3 4 only is given. Okay, this can be done also. Next question is, how do I select a panda series from a data frame? How I will select a series from a data frame? Series means any column. So I will select it. So let's say I read a data frame from using pd.read table. You can use pd.read table also. This one is very common, everybody using, that is called read underscore csv. If it is a csv file, if it is a common file, you can use read table. Or if it is a csv, means comma separated values, means here the delimiter is comma, so you don't have to use read underscore table and put separator as comma here. Instead, you can directly use a function called read underscore csv if that data set contains comma separated values. So directly you can use this function to read into the data frame. So you can use this one, and when you do UFO read, it will give you the 5 UFO.head. It will give you the first 5 rows of that data frame. Okay, and to select every column or series, what will do, you just write UFO and within bracket give the name of this column. What column you want? Let's say I want to only print the column of city, so you just write UFO within bracket, in single quotation write city. It will give you these column only. Or you can also use a shorthand notation using dot notation, that UFO dot city. So either one can be used. Okay, but mostly this one will be preferred, because many times this dot will not work. Where it will not work? You see, if the field is separated by space. Now the name of the column is colors space reported. So if you use UFO dot colors space reported, it will give you error. But if you write UFO within bracket in single quotation colors space reported, it will give you this series. So let's see this one. So it is UFO within bracket save reported, so it will give you that column. But if you write just UFO dot, because as it has a space, so it will give you error. Okay, because invalid syntax. So this is not there. So that's why it is better to use this square bracket and with semicolon to colon to access any row, any column. Okay, so here I have written that bracket notation will not work. So dot notation does not work if there is a space in the series name, and dot notation does not work if the series has the same name as data frame methods like head, save. So we have already used that head method or head attribute. So this head, if it is a name of a column, then you cannot use dot. Okay, this is a limitation. That's why it is better to use within square bracket than this one. And if you have a data frame, what you can do, you can combine two or three or more than one data frame to create a new series. You combine two or three series in one data frame to create a new series and add it as one column in that existing data set. What you have to do, let's say previously we have just see, we have state and we have city. So let's say I want to combine the contents of city and state and create a new column within this data set that will give you the address. So what I can do, I can create a new column name. How? Now let's say write UFO dot location. You can use within bracket also. UFO dot location equal to UFO dot city plus comma, this is string, plus UFO dot state. What it will do? It will take the column city and the column state, combine them, these two using addition, means they will be string with this comma in between, and that will be assigned to a new column whose name is location. So you see, when you run it, previously location was not there, now you will have a location. Okay, it's not, wait, just this one.
Answer will complete at 8:30.
Okay. So this is a location. Okay, so that can be done. Now, next question is, why do some pandas commands end with parenthesis? So already we know this is a very common thing, that if you want to use a method of a pandas class, then there will be parenthesis. If we use any attribute, then or any attribute, then we don't need any parenthesis. Like this here, the read CSV, we need parenthesis because read CSV is a method. Like head is a method which will give you the first five rows, but describe is another method which will generally gives the summary statistics, basic summary statistics of numerical values of that. So it is a method, but this is attribute set, so we don't need any parentheses. So movies dot set, like in numpy there is a sep method attribute, here also there is a sep attribute which will give you how many rows and how many columns are there in the data frame. So here movies has 979 rows and 6 columns. Okay, similarly d type, it will give you data type. So this data type is float 64 object, etc. Okay. Okay, now question is, how do I rename columns in pandas data frame? You can rename it. So once you read the data frame, you can assign new names of the heading of the columns using the dot columns, using the dot rename function. So this dot column will give you what are the names. So UFO dot columns attribute will give you what are the existing names of the column. But if you want to rename it, you can rename any column. Let's see here, I want to rename 2 columns. So I'll write UFO is the data frame dot rename method, and I'm passing the column argument as a dictionary. Here colors reported, previously it was colors reported, this one, and I want that underscore will be there, so it will be converted to colors underscore reported. Shape reported, it will be converted to shape reported. Now I am writing in place equal to true. In place equal to true, if you write, what it will do, it will change the original data frame. It is not temporary, it will permanently change that. So when you run it, then you see previously it was colors space reported, now it becomes colors underscore reported, shape underscore reported. So you can change like this. Okay, you can give also new name also, no problem. And if you want to replace all the names, so you can create a list of these new names. Okay, and just assign the this list to its columns attribute. So UFO dot columns, just assigning this list. So what it will do, so here what I have done, I have just changed the letter, first letter. Previously first letter was capital, now it becomes small. So now it is the new column name is this. Okay, So the documentation is also there. You can refer to this documentation for more details. Now, how do I remove columns from a pandas data frame? How will remove it? So you want to remove some column. So to remove a column, a particular column, we have a method called drop. So once you read this, just you read the data frame, that is UFO, and I want to drop a column. So this drop, let's say this column I want to drop, that is colors reported, axis equal to 1, in place equal to true. In place equal to true means permanently it will be deleted or dropped. Axis equal to 1, the same concept like in NumPy, the same concept here we are using. 0, axis 0 means row, axis 1 means column. In the last class someone has asked, unable to understand. So remember, for a general case, axis 0 means it will treated row, axis 1 means column. But if you are applying some mathematical operation, so it will treat axis 0 means actually it will treat as a column. That means across rows it will do apply that mathematical. Or axis equal to 1 means it is column. But actually if it is a mathematical operation, it will look like a row, but actually it is across the columns it is applying that mathematical operation. That means here it is not a mathematical operation, it's just a drop. So drop means axis equal to 1 means it is column, so just a simple column will be dropped. So you see what I've dropped, colors reported. So this colors reported column which contains NaN, so it is dropped. Now only I have these 4 columns. Is it okay? So everybody clear about axis? When it is a mathematical operation, axis 0 means across row, which means column. Axis 1 across column, which means row. But if it is not a mathematical operation, it is direct like this drop. So axis 0 means direct row, axis 1 means direct column. Okay. Similarly, this you can drop not one but more than one column also. Just pass this as a list. Here axis equal to 1 means I am dropping column. So another 2 column has been dropped. Only 2 is remaining. Okay. Also, you can drop rows. So how you will drop rows? So for dropping row, you have to identify which row you want to drop. So how will identify row? Row can be identified by their indexes. These are the index 0, 1, 2, 3, 4, which are automatically given. So suppose I want to drop 1 and 5. 1 and 5, 5 is there, and because I have only printed 5 first 5 rows, that's why 5 is not displayed here. So if I want to drop that, what I'll do? So same UFO drop, just you pass the list 1, 5, but here you have to give axis equal to 0. Axis 0 means row. So this row 0, 1 will be dropped, row 5 will be dropped. In place equal to true means actually it is going to be dropped. You see, in when you print it, there is no 1, there is no 5. Okay. So this is called axis. Now comes how do I sort pandas data frame or a series. So for sorting the values, so once you read the data frame, there is a function available called sort underscore values. So if you want to sort on a particular column, so just select that column. How will you select? Movies within bracket title, or you can write movies dot title. So it's better to use a square bracket dot sort underscore values. So it will sort all the rows according to the title. So here sort values means ascending is basically in ascending order. So you see when you print the head, this is printed. So this dot, again another dot, this is called chaining. So you chain, you can chain different commands. That means first movies title will be found, means that series will be obtained. Then on that series sort value function will be applied, and whatever new data frame it will give you, on that you apply head. So that means first 5 of that resultant data frame will be displayed. So this is this. So you see it is in ascending order. If you want to descending order, just pass on this sort underscore values that ascending is false. Is it okay? Similarly, on a series, the total data frame can be sorted. So if you want to sort on the total data frame, what you do? Movies, just call the data frame dot sort values on the title. So automatically all will be sorted according to the title. Okay. Similarly, you can use ascending and descending. Ascending is false means it will do the descending order. You can also do sorting on two, means first on content rating. Once all the data frame has been sorted, then it will use duration. So that also can be done. Okay. Next is, how do I filter rows of a panda data frame? So to filter, what we can do, we can use this manual writing manual functions, or sorry, manual loops. Otherwise, I'm going to directly show you what you can do. You can use only one liner like this. Suppose I want to filter out all those rows which has a duration column value greater than 200. So what you can do, directly you can write the data frame movies within bracket, you write movies dot duration, means that series will be selected which is greater than equal to 200. So which is greater than equal to 200, only these rows will be there and all other row will be removed. Okay, so you see here, this has only, the duration has only this 200s or more than 200. This is in one line you can do it. Okay. Similarly, this one also same thing. You can apply movies or duration and along with genre. So that also you can do directly. So that on two rows and columns, both will be sorted. Both will be means removed using LOC. So multiple filter also you can apply. Multiple filter I will apply using and or not, like this. Just I'm showing you one example. This one. So here movies dot duration greater than equal to 200 and